Tungsten. Tungsten looks like your typical elemental metal, grayish-white and lustrous. It has the atomic number 74 and chemical symbol W. The W came from wolfram, another term for the element. Tungsten came from the Swedish Tungsten, which means hard stone. And wolfram came from wolframite, the mineral used to first isolate tungsten. Tungsten's existence was suspected by Carl Wilhelm Scheele when he discovered tungstic acid could be made from the mineral scheelite, named after Scheele, and then called tungsten. 2 years later, brothers Jose and Fausto Alhujar found an acid made from wolframite, similar to tungstic acid. Later on, the brothers were successful in isolating tungsten by reducing tungstic acid with charcoal and were credited with the element's discovery. Older versions of the incandescent light bulbs contained a coiled filament of tungsten, but these tungsten bulbs were eventually phased out by some countries because they are inefficient at converting electricity to light, thus converting more electricity to heat than light energy. In other words, tungsten filament bulbs consume a lot of electricity, but the light they produce is dim. One cannot be a metal element and not have alloys with other elements. Tungsten is an ideal metal to produce heavy metal alloys due to the element's density and hardness. One of the tungsten alloys is high-speed steel, containing an estimated 20% tungsten, primarily used as a cutting tool. High-speed steel is the metal that makes up power saw blades and drill bits. High-speed steel can withstand high temperatures without losing its hardness and can cut faster than high-carbon steel, thus earning its name high-speed steel. Tungsten also has a high melting point, which makes it useful as a rocket engine nozzle and other aerospace and automotive industries and radiation shielding. Tungsten is a component in some superalloys or alloys with superior mechanical strength, resistance to permanent deformation due to excessive force or extreme exposure temperatures, good surface stability, and higher resistance to corrosion or oxidation than typical alloys. Hastelloy and stellite are examples of tungsten superalloys, and they are used in turbine blades and abrasion-resistant coatings and parts. Tungsten is also used as a gold substitute in jewelry because the two metals have similar densities. Metallic tungsten is also hypoallergenic, so people with more sensitive skins would be able to wear jewelry. Moreover, tungsten alloys are harder than gold alloys, making them perfect for rings with complex designs, carvings, and engravings, as tungsten rings resist scratching better. However, these alloys are of course not as hard as tungsten alloys, intended for industrial purposes.